Hello, Matthews. In this video, we're going to cover section 3.2, acceleration. Acceleration is how velocity is changing, and it's usually changing as a result of a force. So something like gravity, pushing, pulling an object. So the derivative of the velocity function will give us acceleration, or the second derivative of the position function. So starting with the position function, the first derivative is velocity, the second derivative is acceleration. Now, acceleration is positive or greater than 0 when the force is moving away from the initial position. Acceleration is less than 0 when the force is moving towards the initial position. And acceleration is equal to 0, meaning there is no force on the object, so that the velocity can be constant. So kind of think of that as cruise control. So our position function had linear units like meters. Velocity had a unit that was a rate, meters per second. Acceleration has units where the time is squared, so meters per second squared. So I want you to think of velocity to the position function as acceleration is to velocity. So let's try an example here. We have this position function, distance is in meters, time is in seconds. I want to find velocity, acceleration in general, and then acceleration after 3 seconds. So velocity is the first derivative of the position function. Okay, so velocity is the first derivative of the position function. So velocity is the derivative of t cubed plus the derivative of 2t squared plus the derivative of 2t. So that's what velocity is. Now acceleration is just the derivative of velocity. So I'm going to take my velocity equation and I'm going to do the derivative of that. So acceleration is equal to the derivative of 3t squared is 6t plus the derivative of 4t is 4. So that's my acceleration in general. Now, if I want to know my acceleration at 3 seconds, I just simply replace t with 3. So the acceleration at 3 seconds is 6 times 3 plus 4. So that's 18 plus 4, which is 22 meters per second squared. So that's what acceleration would be. Okay, let's look at this one. A ball is thrown upwards with an initial velocity of 24.5 meters per second and a position function given by the equation. Find the acceleration function. Okay, so let's do our velocity first. So looking at velocity, velocity will be the first derivative of the position function. So velocity will be the derivative of 24.5t, the derivative of that is 24.5, minus the derivative of 4.9t squared is bring the 2 down and multiply it, 9.8t. So that's my velocity. Acceleration is the derivative of the velocity function. So taking the derivative of that function, the derivative of 24.5 is 0. The derivative of negative 9.8t is just negative 9.8. And so the acceleration in general is negative 9.8. Now that number might be familiar to many of you as the force of gravity. So when an object is thrown or dropped, it experiences a constant acceleration due to gravity. And that unit is about 9.8, negative 9.8 meters per second squared. Negative because I'm coming back down. So gravity is pulling that object back down. So now that we've seen how to calculate acceleration by taking the second derivative of the position function or the first derivative of velocity, let's talk about how I know if something is speeding up or slowing down. So objects are speeding up if the velocity and the acceleration move in the same direction. So I want you to think of, for example, tailwind or going down the stream in the river. So if you have water and you have my very artistic notation of the boat. The boat has velocity, and let's say the boat is moving in this direction with velocity. If the current is acting in the same direction as the boat, it is going to push the boat faster. So the object is going to speed up. Now, objects will slow down if velocity and acceleration are in opposite directions. So let's say I have that boat in the water now, and it's going in this direction, but it's going upstream, which means the current is pushing it back. Well, the current is going to push against the boat because they're acting in opposite directions. Therefore, it will slow the object down. So objects speed up when velocity and acceleration move in the same direction. In other words, they're both positive or both negative. They slow down if they are opposite directions to one another. So let's look at this question here, and we're going to do several parts to this question. So we have a position function of a particle moving on a straight line. And I'm going to tell you that S of t is distance measured in meters, and t is time measured in seconds. So I want to determine when the acceleration is 0. So acceleration. So let's start with our position function. We'll start with finding velocity, which is the first derivative of my position function. So the derivative of 2t cubed is 6t squared, minus the derivative of 21t squared is 42t, plus the derivative of 60t is just 60. So that's velocity. To find acceleration, I just take the derivative of my velocity function, which is the second derivative of the position function. So the derivative of 6t squared is 12t. The derivative of negative 42t is negative 42. So that is my acceleration function. And I want to determine when the acceleration is 0. So basically, I take my acceleration and I set it to 0. So 0 equals 12t minus 42. So I will add 42 to both sides and then divide both sides by 12. So 42 divided by 12 is 3.5 seconds. So at 3.5 seconds, the acceleration is 0, which means I'm going at a constant velocity. Next part of this question asks, when is the acceleration positive and negative? So let's look at when the acceleration is positive, meaning it's greater than 0. So our acceleration was 12t minus 42. I want to know when that's greater than 0. So add 42 to both sides, divide both sides by 12, and when time is greater than 3.5 seconds, acceleration will be positive. So acceleration is positive when time is 3.5 and beyond. Let's look at when acceleration is negative. So I want to know, when is my acceleration negative? So when is a of t, let's try this again here, a of t, okay, there we go. So a of t, when is that negative? So 12t minus 42, I want to know when that's less than 0. So let's just tidy this up a little bit, there we are. Okay, so when is acceleration less than 0? So add 42 to both sides. When is 12t less than 42? Divide both sides by 12, and t is less than 3.5. Now I can't just leave it like that, because less than 3.5 implies all numbers less than negative than 3.5, including negatives. And we know time can't be negative, it has to be positive. So I know that my acceleration is negative. The smallest time that I can have is 0 up to 3.5. So I don't include 3.5, but let's see if I include 0. When I have acceleration being 0, so if I put, when time is 0, when I put time into my acceleration formula here, 12t minus 42. 12 times 0 is 0. Take away 42 is negative. So at time equaling to 0, it is negative. So I can include the 0 as part of my solution. Okay, now that we've done a couple practices of doing acceleration and when is it positive, when is it negative, I want to look at our last example where we're going to look at speeding up and slowing down. So in this question here, we have our position function. The position is measured in centimeters, time is measured in seconds. So I want to know at what time or times is the velocity equal to 0? And what does this indicate about the motion of the object? So let's find our velocity first. Velocity is simply the first derivative of my position function. So the velocity will equal to derivative of t cubed, 3t squared, minus the derivative of 12t squared is 24t, plus the derivative of 45t is 45. Okay, so that's my velocity equation. I want to know when it equals to 0. So I'll substitute in 0, and then I will solve. Okay, so first thing I notice is that 0 is a greatest common factor. So let's just take that out by dividing each term by 3. So then I get 0 equals 3. Two numbers that multiply to positive 15 add to negative 8. So that's negative 5 and negative 3. Okay, so now that I've factored it, I just set each factor equal to 0. So this factor here gets set to 0, and that's time equals 5. This factor gets set to 0, and time equals 3. So at 5 seconds and 3 seconds, the velocity is 0. And what that means is that the object is stopping or changing direction. So at 3 seconds and 5 seconds, the object stops or changes direction. So the object will stop moving or change directions. Okay, next part of the question says, when is the acceleration 0, and what does that mean? So let's find out what acceleration is. So acceleration is the first derivative of velocity. So in our last question, we found out what velocity was, and the velocity, let's just write that down so we have it here, was 3t squared minus 24t plus 45. So acceleration will be the first derivative of that. So let's try that again. Acceleration equals, so first derivative. So the derivative of 3t squared is 6t minus the derivative of 24t is 24, and the derivative of 45 is 0. So that's my acceleration. Now I want to know when acceleration is 0, so I'll set this whole thing equal to 0. So 6t minus 24. Okay, and then let's factor. So 6 times t minus 4. So setting this equal to 0, I see that t equals 4. So at 4 seconds, my acceleration is equal to 0, which just means that I have a constant velocity. Means I'm neither increasing or decreasing. So kind of think of it like cruise control. Okay, and the last part of my question, I want to know about the speeding up and slowing down. So when is the object speeding up and when is the object slowing down? So let's go back to my velocity equation. I did have a GCF of 3, so I'll just include that there. And I'm going to do sign analysis. So I want to know when is the object speeding up or slowing down. When is the velocity positive and negative? That's my first step. So I start at 0 because time at 0. I have 3 and 5 seconds because I know that's when my velocity is 0, so meaning I stop or change directions. So let's go ahead and do our sign analysis. So 3 is my constant and it is positive in all my intervals. Let's look at my first factor, which is t minus 5. So t minus 5 is 0 when t equals 5. So right there, that factor is 0. So to the left of 5, the factor will be negative. To the right, it will be positive. Okay, let's look at my next factor. Let's look at t minus 3. So t minus 3 will be 0 right there at 3. So 3 minus 3 is 0. So to the left of 3, t minus 3 will be negative, and to the right it will be positive. So velocity is the product of those factors. So let's look at the product here. So we have a positive times two negatives, so that means that velocity is positive here between 0 and 3. It will be negative between 3 and 5, and it will be positive greater than 5. So that's the first part of determining if it's speeding up or slowing down, is determining where the velocity is positive or negative. The second part is figuring out acceleration. So I'm going to take this velocity time graph here, and I'm going to add on to it acceleration. So I have it in two different graphs. You can really do it in one. I just want to show you what I'm doing. So acceleration, and again, we had a 6 in front of here, so let's just leave that there, okay? So 6 times t minus 4, that's how it factored. So notice what I have on here. I have when velocity was 0 at 3 and 5 seconds, and then I've added on the 4 seconds. So let's just plot what we've already figured out about velocity. We saw between 0 and 3 seconds that velocity was positive. Between 3 and 5 seconds, velocity was negative. So I'll put it in both of those, negative. And then beyond 5 seconds, I saw that my velocity was positive. Okay, so now to this, let's add acceleration. So looking at acceleration, I'm multiplying by 6, which is a constant value, meaning it will be positive in each of these intervals. And then let's look at my t minus 4. So the factor t minus 4 is 0 when t equals 4. So to the left of 4, that factor will be negative. To the right, it will be positive. So now what we're going to look at is the acceleration in each one of these intervals. So a positive and a negative means acceleration is negative. Positive and negative, this means that acceleration is negative. Positive and positive, acceleration is positive, and positive means that acceleration is positive. So to look at where something is speeding up or slowing down, let's look at where the signs match. So see here how velocity is negative and acceleration is negative? They're moving in the same direction. So negative velocity means I'm returning to my initial position. And acceleration negative, meaning the acceleration is pushing that object in that same direction. It's also the same here and here. So in those intervals, I'm going to say that it is speeding up because it matches in sign, okay? So let's write that down. So I'm going to say that the object is speeding up, and it will be speeding up between 3 and 4 seconds, or between 5 and positive infinity, so beyond 5. Okay? When the signs don't match, such as here, where the velocity is positive, the acceleration is negative, the velocity is negative, the acceleration is positive. Since they do not match, that means that I will be slowing down. So I'm going to be slowing down between 0 and 3 seconds, or between 4 and 5 seconds. So that's how you can figure out speeding up and slowing down, by figuring out signs of acceleration and signs of velocity. When they match, I'm speeding up. When they don't match, I'm slowing down. So I hope that this lesson helped. And as always, I hope that the mass times acceleration will always be with you. And hopefully those of us, especially those of us in physics, know that mass times acceleration is truly force. So may the force be with you. Oh my goodness, if I can write it here. May the force be with you always. Okay, I hope this video helped, and I look forward to seeing you guys for the next one.